Ready.
Welcome to SJCE Content. I am Dr. D. Shobha, Assistant Professor in Department of Physics, St. Joseph College of Arts and Science, Kadalur. In this video, I am going to discuss viscosity. Viscosity is the basic property of liquid. Which gives rise to viscous force. What is viscous force? It is a tangential backward dragging force between two layers of liquid. This dragging force opposes the relative motion between the layer of liquid. For example, we consider water and sugar syrup. Water is a low viscous liquid. Whereas sugar syrup is highly viscous. It will easily flow, but sugar syrup won't easily flow. This is about the viscosity of water and sugar syrup. That is, simply we can say how the liquid is flowing. That property is called viscosity. Now, we can see about the coefficient of viscosity. It is usually represented by a letter eta, which is equal to the ratio between shearing stress to velocity gradient. So we can find out the coefficient of viscosity. Let us consider a liquid flowing in a horizontal surface. This is an horizontal surface. In which we are considering a liquid flowing. The flow is streamlined, so it will have the layers. This is the layer which is the contact with the horizontal surface. This is the top layer. The velocity of this layer is greater than the velocity of the layer which will be contact with the horizontal surface. Here the velocity v equal to 0. But it has the maximum. The velocity is maximum. Why the top layer has the maximum velocity compared to the layer which is contact with the horizontal surface? Because between the two layers, some backward dragging force, that is backward dragging force acting between the two layers, so that the velocity of this layer is reduced by this top layer. Simultaneously, the velocity goes on decreasing towards the horizontal surface. So, we can consider two layers. It has the velocity v, another one have velocity v plus dv. So it is again increase in velocity. The distance between the two layers is dz. Here the velocity gradient is equal to dv by dz. The viscous force, in this case the viscous force F, we are considering the viscous force is F, which is directly proportional to area of the layer. Then velocity gradient dv by dz. Viscous forces depend on the area of the layer and velocity gradient of the liquid. So we can write the viscous force. Removing the proportionality, we put a constant called beta is the constant called coefficient of viscosity. So by removing proportionality we put the constant, that is called coefficient of viscosity. So we have A here and velocity gradient dv by dz. We can write F equals the coefficient of viscosity neta from this relation, which is equal to F divided by A divided by dv by dz. On simplifying this, we can get this relation. Here F divided by A is the shearing stress and dv by dz is the velocity gradient. So the coefficient of viscosity is the ratio between the shearing stress to velocity gradient. The unit of viscosity. Unit of coefficient of viscosity is Newton second meter in per meter square, or we can write Pascal second. This is the unit for coefficient of viscosity. Next we are going to see about the dimension of viscosity. Dimension. Dimension of coefficient of viscosity. We have the coefficient of viscosity is the theta equal to force by area whole divided by velocity gradient dv by dz. So we have force. The dimensional formula for force is ml t power minus 2 divided by area is L square and dv by dz. So v is the velocity. So velocity have L t power minus 1 and d is at the distance, so L. On simplifying this, we get eta equal to ml power minus 1 t power minus 1. This is the dimensional formula for coefficient of viscosity. Next, definition for coefficient of viscosity. We already derived the coefficient of viscosity is equal to force by area whole divided by velocity gradient dv by dz. If here A is the area cross section of the layer. And dV by dz is the velocity gradient. If A equal to 1 and the velocity gradient dV by dz equal to 1, then the tangential force, that is viscous force is equal to the coefficient of viscosity eta. If you put A equal to 1 and dV by dz equal to 1, we get F equal to eta. Then we can define tangential force required. Tangential force per unit area. Required to maintain unit velocity gradient. This is the definition for coefficient of viscosity, because if we are taking the area of the layer is equal to 1 and velocity gradient equal to 1, we get F equal to N. That is tangential force per unit area required to maintain unit velocity gradient. This is the exact definition for coefficient of viscosity. Next we are going to see application of viscosity. The first application is used as a lubricant. The knowledge of coefficient of viscosity is useful to select the lubricant for machineries. Then it is used as a brake oil. Oil in some hydraulic brakes. Third one, used to find the molecular weight of the liquid. The knowledge of coefficient of viscosity helpful to find out the weight of the liquid, that is molecular weight of the liquid. Fourth one, used in gum. Then the flow of blood in a vein. Flow of blood in vein depends on the viscosity of the blood. These are some application of the viscosity. Thank you.